Good soul to everyone. Today I'm gonna talk about the engineering center. That is my facility. My name is Maria Jose Palacios and I am from Ecuador. Here we have an overview about the topics that we're gonna talk, like internal design, machines or technologies necessary for the operation for the installation, possible resources to generate in situ or transport from Earth, organizational structure, positions, profiles, and data, astronaut training program, YouTube videos to train astronauts, resource need for 1 week, guidelines to be provided to other facilities or entire station. Another topics are specific protocols or routines of the facility, protocols of safety, protocols for occupancy entertainment, protocols for food microproduction, protocols for 3D printing, some material products, technologies and outputs that could be applied to Earth, guidelines to be applied to daily life on Earth, and the last topic is impacts to Sustainable Development Goals, SDG. First, we're gonna talk about the internal design. As you can see, here is our habitat, but especially we're gonna talk about the engineering center. The design that we have is that the habitat has 3 floors. Okay, here we have the 3 floors of the engineering center. First, I want to say that it is my own design. I did it on a platform called Tinkercad. In the first floor, we have the machinery center. In the second floor, we have the research room, and on the last floor, we have the rest room. In the machinery center. The machinery center has gates to provide oxygen, has a place to store astronaut exploration suites. In this floor, there is the 3D printer, there is habitat cameras, there is the control center for lighting systems and the amounts of oxygen, water, and food. And there is the call center too. The research room. In the research room, we have a little garden, the research machines, and there is a little place to prepare food too. And at the last floor, we have the rest room. In the rest room, we have beds, a bathroom, and gym. It's very important for astronauts to do exercise. Now we're going to talk about applied technologies. First, we have the machines or technologies necessary for the operation of the installation. I divide it on the 3 floors. In the first floor, we need the 3D printer, computers, cameras, and rovers for the exterior. On the second floor, we need microscopes, a microwave for the foods, and here we have all the lab material, like thermometers, pipettes, and all the rest of material for lab. And on the last floor, we have beds, treadmills, and the laboratory. Now I'm gonna talk about the possible resource to generate in situ or transport from Earth. In the first square, we have the resource to generate in situ, like fuel. How we're gonna generate fuel? Because in Mars, we're gonna use the water found, and we can separate the oxygen and hydrogen, and with that we can get fuel. We also can get meals. With the little garden that we have, we can grow our own plants and we can eat it. We can generate solar energy because we're gonna have panels and we're gonna capture all the solar rays. And we're gonna generate tools too. How? Because we're gonna print it with the 3D printer. The resource that we're gonna transport from here are all the materials for research and for laboratory. Now I'm gonna talk about the management. The organizational structure. At first, we have the mission commander, and then we have a systems engineer, a robotics engineer, and an environmental engineer. The positions and astronaut profiles and duties. The mission commander. He gives permission to enter and exit to the habitat, and he directs operations. Then we have the systems engineer. He controls electricity and communication systems. Then we have the robotics engineer. He manages rovers and AI technologies. And the environmental engineer is in charge of the food and control of the garden. I want to say that all those people has access to the lab. The astronaut training program. At first, we have the topics of training. Something very important for the astronauts is the psychological training. But we have the training in operational systems. Something else that is very important is first aid in case of emergency. We have a training for how to have good relationships with colleagues, how to survive to extreme situations, and the last we have the physical training. Here I have some YouTube videos to train astronauts. I put it here some videos that we can use, and we can learn some things like things you can do to improve your mental health, or fundamentals of system engineering, or how to survive in space. Now I'd like to talk about the resource need for 1 week. First, the system generates between 2.3 and 9 kilos of oxygen per day. This is enough to sustain 6 astronauts, but in this case, I be the only one in the facility. Another resource, very important, is water, and each astronaut consumes about 3.5 liters of water per day. And the least we have the food. Each astronaut consumes 3 meals a day, which 1,000 calories each. That is, a total of 3,000 calories. If we wanna consume this for 1 week, we have to multiply it for 7. Now, here we have guidelines to be provided to other facilities or world station. First, have activities on a schedule, check systems from time to time. We have the team collaboration, the self-sustainability and survival, growing own plants, don't skip meals, and solve problems as a team. The protocols. We have a lot of types of protocols, and I'm gonna talk about some of those. First, we have the specific protocols or routines of the facility. Simulation for the analysis of possible failures in case of fires in providing security conditions. Another very important is the hygiene protocol, the protocol in case of hack, and the meal quantity control protocol. But I say that we have another types of protocol, and there is the protocols of safety. I'm gonna repeat two protocols, like simulation of analysis of possible failures in case of fires, improving security conditions, and the protocol in case of hack. But we have another's, like protocol in the lab, determinate use of a certain amount of chemical and no theft of the database. Another type of protocol is the protocol for occupancy or entertainment. First, we have the celebration of special days. The astronauts can celebrate birthdays and special days of different countries. They can watch movies or series. They can communicate with the family too. They can do yoga or do exercise on a little gym. They can read books, play games, or listen to music too. We have the protocols for food microproduction too. First, we have the food collection protocol. Then, plant growth protocol. Take care of plants, report garden status, determine if the plant grows healthy, watering plants, provide correct lighting and temperature. And we have the protocol for 3D printing. We have only print necessary tools to avoid material wear. We can print different tools for the lab or for the call center. Now I'm gonna talk about the spin-offs. The technologies and outputs that could be applied to air. Consumed energy control system, printing in 3D, recycling, technologies for water care, communication technologies, and at the least, digital learning. Guidelines to be applied to daily life on Earth. First, we have the correct water consumption, the good nutrition, be self-sufficient, routines to proper mental health, and healthy relationships with peers. Something very important is to have a good relationship with our mates. And now we have the impact to sustainable development goals, SDG. There is no waste of energy in engineering center, recycling, care of the planet, be self-sufficient another time, establish good relationship again. Here we have some reference that I used to put my information here. And at the end, this is the way you can contact me. My Instagram is she's Jojos, and there is my Gmail too. That was all. Thank you.
Okay, Maria, thanks so much for your presentation. Yes, I really like it. How do you prepare it, the content? Yes, yeah, I believe it's very important. We imagine how the engineering can support the space exploration, because There's a lot of challenges. Also, one of the things that I was yesterday, I was watching a video in YouTube, commenting the challenges, the challenges in terms of SpaceX rocket, the Starship development, how this, because now they are preparing the second launching of the Starship, and they will try to do a orbital launching with Starship, because the first launching explode some minutes after the launching. Yes, and the Starship will be very important logistic system to arrive on Mars. And yeah, and we need a very challengeful aspects to think about how how this will be possible, and how the engineering can contribute to this. And yes, because of this, engineering is a very important topic about space exploration. Yes, and I'd like to say thanks to your presentation. Also, if Shirey has more comments, you are welcome, Shirey.
Yeah, no comments actually, but I want to ask about the Capcom, about the Capcom. If you have any idea about the Capcom, or how can we go in the Capcom in the for the Mars mission?
Would you repeat the question? Sorry, about the Capcom. Yeah, also I'd like to because one of the points about the engineering facilities is presents some support to the
Mm,
landscape exploration, right? And
mm,
it's very interesting to think about how there would be established the communication between the astronauts during the extravehicular activity and the station, right?
right.
Yeah.
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 Actually, the presentation is very good. So, if you don't have any problem, then we can go. Sir, did you send us? I think regarding the call for papers, right?
Yeah.
Yeah, we can use your idea in that presentation also for the papers, because it's very good idea. Your
Yeah.
presentation is very good.
Yes, Maria. One of the interesting things that she raised, remembering how you can transform your presentation in an abstract.
Right, exactly.
Yes, to submit to. We have the Mass Society Convention that will be happening I believe it's Arizona, and also, but in Mass Society Convention is also possible remotely from Ecuador, for example. And also we have the Space Habitat event. Also be sharing more details about the Space Habitat event in our group. More details about and if possible, you transform your presentation in a 300 words abstract. Would be interesting to we
Yes, exactly.
we submit to these both congresses.
Yeah, because you presented very well and you have a clear idea.
Yeah, it's very
Okay.
objective, very.
So I send you the presentation.
Sorry.
I have to send you the presentation.
Yeah,
Uh, yeah. Or you can participate also.
Okay.
yeah,
Yeah, you can go because you have all the points and you have the clear idea and you already presented it very well.
Thank you.
Yeah.
yes. I share in the group the call for
Yes.
papers for the Space Habitat event. It's good, well remembered by Shireya. Also, I'll be sharing our social media about remembering again about be important. The people submit the abstracts. Yes, and you are welcome, Maria, to transform your presentation in a in a abstract for this congress. You need to see the title, but the title the title is okay. You can follow the like engineering for Mars exploration, something like this would be the title. Yeah.
Is
Okay.
this individual or group present paper?
Yeah, I share in the group the call for papers. Also, if
Okay.
possible, you share more. Also, I'll be sharing today in our WhatsApp group. Oh, sorry, in our social media, and also if possible sharing your partners and friends.
Yeah,
It's
yeah,
nice too.
yeah,
Okay.
yeah. Okay.
In this case, our next meeting will be Wednesday, right?
Yeah, it's
Wednesday.
my presentation.
Yeah, at 10 a.m. UTC, the same time that we had the meetings previously, and will be the Sharia presentation. Also, I'd like to remember you, Sharia, about sharing some photo from India. Maria is doing this. Also, I'm also forgetting, but I will share today a photo from Natal. Now I am Natal in my home, and I was sharing some a photo from today is a little cloudy, and I was sharing some a photo about.
Yeah,
Okay.
I'll share. Yeah.
Okay. Thanks so much. More points. So and congratulations again, Maria, for your presentations. It was very well done. And yes, also, Shireya, if possible, you update us about the Israel mission to Moon. Do you know something about if they had success or not?
Yeah, yeah, already the Chandrayaan-3 is entered into the moon orbit, the lunar orbit.
Mhm. And this the objective is land on Mars, the capsule, or only stay in the lunar orbit. Do you know?
The objective is to stay in the lunar orbit because the next year the ISRO will organize the Gaganyaan mission where the 3 astronauts will go in the space.
Mm. Okay. I was thinking that would be something like a lander to walk in the have a movement on the moon, but it's only a orbiter, right?
Yeah,
Okay. Okay, wonderful. Yes. And congratulations to India program to
yeah. Thank you.
yes, it's very good. Yes, and we need
Yeah,
to celebrate. Yes, and in this case, if you identify during this week some opportunities, some online event that's happening, please share. Also, I share
sure.
a event about from NASA, and if you both identify more opportunities, please share in the group. Okay, if I identify more
Sure.
events during today or during this time, I will be sharing too.
Okay, okay, sure.
Okay. Okay, have a nice day. Thanks so
Thank
much.
you.
Good soul. Okay.
Good
Thank
song.
you.
Bye bye.
Bye.